Hey there, mathematicians. How's it going? Welcome to another exciting day of math. Today should be for you Tuesday, April 14th. It is our second day of solving systems of equations. Last class we did some review. How do we graph lines? Today we are going to use that information to graph some systems of equations. So please get your notes out. Your notes for today should look like this up at the top. We are solving systems of equations by graphing. So first things first, Mr. Pratt, what is a system of linear equations? Well, let's fill in that first blank. It is a set of two or more linear equations. So you got to have two equations. You could have more, but today we'll just look at two, and we're going to solve them together. Now, when we solve something, it needs a solution. So number two, the solution of a system is an ordered pair that makes both equations true. So for example, it's going to be some x comma y, maybe it's 1 comma 2 or 3 comma 7, whatever. On the graph of both equations, the solution is where the lines, ready, intersect. That's all you're looking for, ladies and gentlemen. Where do our lines intersect? Now, that leads to some interesting findings because lines typically, if we look at number 4, first graph, lines typically intersect once. They have one solution, one place where they intersect. However, what if our lines are parallel? If our lines are parallel, like we see in the middle graph there, well, then they're never going to intersect, and we would say, okay, the answer is where they intersect. If they don't intersect, there is no solution. Well, okay then, what about lines that are directly on top of each other? What if they have a whole bunch of places where they intersect, not just once, but if the two lines are laying right on top of each other, they intersect infinitely many times. They are always intersecting. We would call that infinitely many solutions. Now, I'm going to show you how to do these problems by hand. Not everyone has a calculator at home. However, you are perfectly allowed to go download a free app on your phone or go on your computer and search TI-84 emulator or calculator app. You can solve these on your calculator. And here's how you would do it. In fact, I'm going to pull my calculator up. You're going to start by making sure both your equations are in the y equals format, and then we're going to type the equations into y equals. So where's my calculator here? Here's my calculator over on the side. We're going to hit the graph button. So I hit graph. Oh, excuse me. Type your equations into y equals. Here they are. In fact, this is one I stole from your homework. So that'll be nice for you to get an answer. So step 3, hit graph. When I hit graph, you see mine. It's all pretty. Hey, look, that clearly has one solution where the red and blue line intersect. Step 4, make sure you can see the intersection point, and if you can't, go to change the window settings. Now, step 5, you're going to hit the second button. I hit it for you. It turned red. And then trace, which is up here at the top. And then you want number 5, the intersection point. So I'm going to hit 5. Then you hit enter 3 times. 1, 2, 3. And it says, here's your intersection. It's where x is 1.6 repeating and y is negative 1.3 repeating. So step 6, your calculator tells you the answer. You write it down. And you'll notice we have two answers. When we solve two equations, we typically have two answers, an x and a y. Okay, back to our presentation. Okay, so let's look at some examples. Under those calculator instructions, we got examples. We're going to do these by hand, not on the calculator. So step 1, make sure both equations are in the y equals format. These clearly are. We have y equals and y equals. Step 2, graph the top equation. Okay, no problem. In order to graph, you see the bullet point, start at the y-intercept and then follow the slope. So the y-intercept is negative 4. Great. Let's put that on our graph. Negative 4. Follow the slope. Now the slope here is 12. That means 12 over 1. We know slope is rise over run. So it's 12 over 1. So I'm going to go up 12 over 1, and my next point is right there. Once I have 2 points, I can draw the line. So there's our first line. Great, that first line's done. Step 2, graph the second equation. Same idea. The y-intercept here, the b value, is at 9. So I put a dot at 9. The slope, what do you think the slope is here? It's the number in front of x, what we would say the coefficient of x. But I don't see a number in front of x. If I can't see it, that's an invisible number 1. So the slope here is -1. Again, we want rise over run for slope. So that's got to be -1 over 1, which means we're going to go down 1 over 1, down 1 over 1, down 1 over 1, until we've got a nice line of dots, and then we put our line through those. Fantastic. We've graphed both of the lines, and we can see where they intersect. Step 4, let's determine how many solutions we have. It looks like we have one solution. We can see where they intersect. Step 5, let's identify where the intersection point is. These lines clearly intersect right there. That point is at 1, 8. So that must be our solution. So you see down there at the bottom I've written x equals 1 and y is equal to 8. And we got that from the coordinates of where those lines intersect. Okay, example number 2 looks a little different, right? The equation up at the top is just y equals 2. Let's go through our steps. Make sure the equations are in y equals format. Done, done. They both say y equals at the beginning. Graph the top equation. All right, let's try to graph it. But this is a special equation, isn't it? This line is special. In fact, if you recall from yesterday, this is what we call a hoy line. Anytime we have y equals a number, it's a horizontal line. So for this one being special, we will draw a horizontal line at y equals 2. So I identified with my dot, there's y equals 2. And then here, whoop, is the line. Beautiful, that's our first line. Step 3, graph the second equation. No problem, the y-intercept is 4. The slope, oh, there's our y-intercept. The slope is -1/3, so we're going to go down 1 over 3, down 1 over 3, and then draw a line through those. Look, you can clearly see we have one intersection point, so we'll have one solution. If you have one solution, identify and label the coordinates at the point. So the lines intersect right here. That's going to be at point 6, 2. That means we want our answer to say x equals 6 and y equals 2, so we're going to put it down here for our solution, x equals 6 and y equals 2. Hope you got the first 2 examples. Let's do one more and we'll be out of here. Same exact steps, y'all. Make sure both equations are in y equals format. Got it? Got it. First 2 both are. Graph the top equation. Great. So we look at our y-intercept. It's at 6. Let's put that on there. Then we're going to see where the slope is -3. Again, that's -3 over 1, so we're going to go down 3 over 1, down 3 over 1, make a whole bunch of dots, and connect them with a line. You have finished your first line. The second graph, or excuse me, the second equation has a y-intercept here of -2. So we're going to start with a dot at -2, way down there. Our slope is again -3, so we'll do the same thing. Down 3 over 1, down 3 over 1, down 3 over 1, and there's our series of dots. Let's put our line in there. Okay, let's determine, do we have one solution? It doesn't look like these intersect. Do we have infinite solutions? I mean, they're not right on top of each other. It looks to me like this is no solutions. So here's what we would write. These lines do not appear to intersect. They look like they're parallel. That's the word. They travel alongside each other, never get any closer, never get any further apart. Parallel. In fact, we can check this, guys. What was the slope for both of these? The slope for both of them was, ta-da, -3. If the slopes are the same, then they travel in the same direction. Therefore, they're parallel. These two have the same slope, so our answer has to be no solution, because the lines are never going to touch each other. So down at the bottom, we write no solution. Y'all, thank you so much for a wonderful review time of learning about solving systems of equations by graphing. Go ahead and get that 5-question assignment done that follows these notes. Have a great day. Take care. Be safe. And if I don't see you again, good afternoon, good evening, and good night.